Hello students, today we are going to solve the fifth numerical. Question is written as the static indeterminacy of the two span continuous beam with an internal hinge shown below is. Here a continuous beam ABC is shown. Span BC will carry an internal hinge which is shown here, and the whole beam is subjected to vertical loading that is shown here. Now we need to determine the total degree of static indeterminacy. Okay students, now we know that total degree of static indeterminacy will be equals to the external static indeterminacy plus the internal static indeterminacy, and we know that the total external static indeterminacy will be equals to R minus S, where R is the total number of support reaction and S is the number of equilibrium conditions. Now due to vertical loading there will be only three support reaction which will be acting in the vertical direction, that is VA, VB and VC. So the total number of reaction will be equals to 3, and the total number of equilibrium condition will be equals to 2. Because of vertical loading we will take only two equilibrium condition, that is movement about any point in this beam is equals to 0 and summation of all the forces in the vertical direction is equals to 0. We are not taking here the horizontal equilibrium condition because no horizontal force is acting on this beam. Okay students, so the external static indeterminacy will be equals to, we will put this value of R and S, we will get 3 minus 2 which will be equals to 1. So the external static indeterminacy will be equals to 1. Now we need to determine the internal static indeterminacy which will be equals to 0 minus internal hinge, because in case of beam the internal static indeterminacy will always remain 0, but if internal hinge is present in the beam then we have to subtract that from the internal static indeterminacy. Now the value of internal hinge will be equals to the number of members connecting at that internal hinge minus 1. Now at this internal hinge there will be two members connecting, so it will be equals to 0 minus 2 minus 1, it will be equals to minus 1. So the internal static indeterminacy of this beam ABC will be equals to minus 1. Now if we need to find the total static indeterminacy of this beam, which will be equals to DSE, that is external static indeterminacy, plus DSI, that is internal static indeterminacy. Now if we put the value of both these, that is plus 1 and minus 1, it will be equals to 0. So the total static indeterminacy of this beam is equals to 0. That is all about this numerical. Thank you very much students.